Good evening, everyone. My name is Menaka. I'm a Senior Learning Manager with the Institute of Product Leadership. I'm very happy to welcome you to another thought provoking webinar session. We have been hosting informative webinar sessions for more than 2 years now. Through our sessions, we try to bring together thought leaders across the globe to share their insights. I hope most of you have logged in and settled in well. Once again, a very hearty welcome. Most of you have attended our previous webinars and most of you are familiar with the Institute of Product Leadership. Still, let me give you a short overview of our institute for the benefit of new joinees. Founded in 2012, we have had the opportunity to work with many product leaders and industry experts. We are dedicated to training professionals in product leadership, product marketing, data science, other emerging technologies, etc. We also conduct programs in university campuses. We have alliances with many respected universities, as you can see here, the CMRIT, the MIT University in Pune, etc. We are also well aligned with many world renowned organizations such as Bosch, ADP, Ericsson, Cisco, etc., across India, Europe, the United States, and Southeast Asia. Before we get directly into the webinar, let me introduce you to some of our upcoming events. So on 24th August 2018, at Ritz-Carlton in Bangalore, we have a leadership summit coming up. This is a good opportunity for you to interact with a lot of industry leaders, understand what is going on in the industry, network, get more insights, etc. So in the chat window, you will see the link for registering into the Leadership Summit. There are a lot of leadership workshops also. If you're a manager, you should definitely attend this. This is a great opportunity for you to interact with a lot of leaders in the industry. My colleague will share the link through the chat window to join the Leadership Summit. Another event that is coming up is the Product Leaders Forum. Many of you would have already attended, I'm assuming. For others, Product Leaders Forum or PLF is India's NGO. It's the only NGO offering a unique product thinking platform for product practitioners. This is a completely volunteer driven forum and it's a great platform for product managers and leaders to put their minds together, share insights, experiences, and network, etc. Again, on your chat window, this is happening on August 31st in Banjara Hills in Hyderabad. Now we have one more PLF happening on 28th and 29th September in Bangalore. This is in Ritz-Carlton. The seats could be a little limited, so please go ahead and register yourself right away. Now let me quickly take you through some of our executive programs. So Executive MBA in Product Leadership, this is our flagship program where we have 1800 plus very successful alumni. So this is an executive MBA program and in alliance with the CMRIT University. Now we recently launched MBA in Applied Data Science in alliance with the MIT University in Pune, taking into consideration how data science as a platform is growing. And International Certificate Program in Applied Data Science is a data science program specifically designed for working professionals with say 7+ years of experience and who want to leverage data science skills and move up their career or better their skill portfolio, etc. We have also a lot of skill boot camps like agile, user experience, data science, art of storytelling, etc. Please log into our website, www.productleadership.com, for all the information. Now, coming to the webinar, you all know that product development is a very hot space to be in today. Now, data science is the sexiest career of 21st century. What if we merge these two exciting platforms? This is what we are going to discuss here today. So how do we leverage data science for product development? How do we uh, create better products with data science? Now, about our speaker, Mr. Pradeepta Mishra, a few minutes does not do justice to his introduction, but for lack of time, I have to cut it short a little bit. So, Mr. Pradeepta is a data scientist by profession. He's an expert in artificial intelligence. He has filed 2 patents as an inventor. He has authored 2 books, one of which will be gifted to our winner today. And this book is very special. I'll tell you why. His TED Talk, he's spoken in TED Talks also. His TED Talk, Can Machines Think, is a very well noted one. Please check it out. One of his books, that is the one I suggested, or we are giving as a gift for the best question in this webinar. It's recommended to be a text in the University of Pittsburgh. And he's an expert in machine learning, data science, deep learning, artificial intelligence, etc. I'm very happy to have you with us, Mr. Pradeepta. I'm handing over to Mr. Pradeepta now. He will take forward the conversation.
Menika, are you able to hear me?
Yes, we can. Yes, we can hear. Yeah, we can.
And you can see my screen, right?
Yes.
Well, thanks. Hi, everyone. Very good evening. Fine. So I'll start with first what is this data-driven product development? And since thanks, Menika, for the introduction, so I would not be repeating the same thing again. So first of all, I would like to speak about like what is this data-driven product? What should exactly be called as a data-driven product? Typically, the product managers they take constantly certain decisions even without enough information to determine what is the right action that is appropriate for a particular scenario. Even more difficult scenario is getting to the end of the project and not being able to measure how successful you were while developing the product. Exactly. So a data-driven product is basically a software or a service or a platform that is able to solve the use cases. So before moving into solving a business problem, first of all, you have to zero in on finding out what are the use cases that I'm going to solve. It utilizes a number of different machine learning algorithms. That is the most recent development. Most recent in the sense I will say like last 5 to 6 years or maybe 6, 7 years, we are seeing a trend that most of the products they contain certain machine learning algorithms built in it because the machine has to take decisions which is most appropriate relating to a particular scenario by using the deep learning and artificial intelligence techniques or methods. So given this background, what is constantly changing over the years is the stream of data is increasing heavily. Structured, unstructured, semi-structured, sensor. There are various forms of data which is pouring from the devices, and this is residing in the huge data lakes and databases. What is important is how do we get strategic business decisions from those data sets, right? So the data science algorithms on the other side also it keeps on increasing. Every day a certain set of new algorithms are coming into picture. Now, when like few years back, we used to use logistic regression, linear regression, random forest, decision tree. For example, those algorithms, the most commonly used algorithms into the day-to-day decision making. However, the most recent algorithms, if you look at the CNNs, the LSTMs, the FTRL techniques, these are most recent developments that are happening in the deep learning and machine learning space. So given this background, how we are going to drive the decisions while developing the products? Here, there is a difference. Using products, using data. So there are certain products you will find they use data. There are certain products they actually be driven by data. So products using data is not equal to data driven products. What does that mean? If we are consuming some data which is residing in some kind of databases or data lakes, and we are delivering the services through APIs, RESTful APIs to some other platform, and we are making or consuming the data, that is not data driven product. What is data driven product is? It's basically products when the decision making happens. That means the amendments that you are doing to the product features, the amendments that you are doing to make the product more intuitive to the user by using some kind of algorithms. Those algorithms are basically could be machine learning algorithm, could be a statistical learning algorithm, or it could be deep learning algorithm. It can be a single algorithm, it can be a bunch of algorithms. So what is important is the data driven product should be significantly different from those products that they use only data to deliver a particular type of services. Hence, the product managers or the data scientists, they can leverage the data to make better decisions and solve everyday business problems, which means the data enables the product managers and their teams to determine whether the project created the expected outcome, if it requires some kind of fine tuning, if we can improve certain processes in delivering the solutions, right? So there is a clear differentiation between the products they consume data and the products that are driven by data. So to me, if you ask me to give some examples, products like suppose let's take a flight aggregator where we are just looking at the flight prices to make a booking or to book a travel. So it's a travel aggregator. He has the APIs, he's getting the current prices from different providers, and he's just listing out the prices to the user. Now as a consumer, we are just making decisions based on the prices, based on the journey date or something. We book a ticket. Now that is not data driven product. That is basically data consuming layer. So we are being the product is being delivering the current prices and the discounts that is available at that moment in time through some RESTful API from different suppliers. However, what is the decision making here? How do you make the decision? Like for example here, you take the same data. Now you run a model in the backend to understand the intent of the user. If the user is simply navigating through the aggregator site and he's not interested in booking the ticket right away, or he is very much interested in booking the ticket right away, probably if we will not give some kind of discount or some kind of levers, he will switch to some other aggregator's website. Now, that is one pointer. So here, predicting the intent of the user to make amendments to your actions to force the user to book the ticket through algorithmic intervention. Now, that is called data-driven decisioning. So you are letting the user book the ticket right away by making some amendments from your side. So the data-driven product should have not only one layer. This is just one use case. There are many use cases. There are many softwares that we see today. There are many applications that we see today. So those applications basically what it constitutes. So it basically constitutes a use case. One application may have multiple use cases. Now, looking at the previous example, the last example which I was giving is like the aggregator's website. One is to predict the intent of the user who is navigating through the website and just doing some searches, etc. From the search result, you are trying to predict the intent of the customer. Similarly, you can create many such use cases. So the use case that matters most to the organization or to the product should be identified first. Now, once you identify the most important use case, then you define the problem statement. So this is the use case. Okay, what is the problem statement? Can I break the problem statement into multiple small problem statements? Or this is the only problem statement? So looking at the problem statement, try to convert it to a mathematical or statistical problem. So that's how the strategy here is, how do I break the problem to make it a math problem or a start problem? Then I look for a particular solution to a particular mathematical problem. Then I'll translate it to a business solution. First, I get the statistical or mathematical solution. Then, once I get the business solution, I'll ask the stakeholders, you let me know if there is any scope for further improvement. Is this right or wrong? That's how you will see the feedback. You ask the stakeholders to provide the feedback. You make amendment to the solution. Sometimes it may require a different solution at the statistical or mathematical level. Sometimes it may require a different solution at a translation level, where you are translating the mathematical solution to a business solution. Now, once you make amendments, that is finalized, the feedback of the stakeholders are already taken care of, then you'll go for optimizing the solution. You'll optimize, then you deploy, that's all. So that's the strategy which you will take while going into the product development. The next step is identify the task. While defining the problem statement here, and before converting it to mathematical or statistical problem, now in between, like defining a problem statement to getting into a math or stat side of it, it's important to look at what is the task. Now, is it a simple task? I can simply write a if else condition or a loop probably to solve the problem. Of course, yes. So there is no need for algorithm. Sometimes certain problems doesn't even need any mathematical or statistical techniques. This could be simple logic. This could be simple, a kind of like a logical, you can say any kind of logical model. So where algorithmic intervention is required, then you have to decide what category of problem it is. Is it a supervised learning problem where you know the outcome, you know the input, you just need a function to map the input to the output? However, the second step is basically you don't know the output, you only know the input. From the input, you want to get into identifying the directions. So unsupervised, where the outcome is uncertain, we don't know. We simply know the input. So by looking at the input, can we apply some kind of unsupervised learning algorithms there to get a logical association or some kind of model-based association? Next, semi-supervised, where you know some outcome and the other outcome is something which the machine need to predict that we don't know. Similarly, the last phase is basically the reinforcement where we constantly seek the feedback to improve the process better and better. So we make some changes, we get a feedback, we correct it. For example, like the smartphone. So we nowadays, or now like maybe since last 4 5 years, we are constantly seeing that every second month, third month, a new smartphone is being launched in the market because they constantly take feedback from people. Something is not working, change it, launch a new product. Something is not working, something is could be made better, some features are not right, some features should be upgraded, some technology is coming up. So they constantly develop the product, they constantly change the configurations, the features, the attributes of the product, the look and feel, etc. So they constantly invent certain stuff, and using the reinforcement layer, they seek feedback, make corrections, launch a new product, right? So before getting into the development step, also it is important to identify what is the task that I'm going to solve. Then iterate till perfection. This is important. Now you have already got the problem statement from the use cases. Now you have already identified the task, which category of task it is. Is it supervised? Is it unsupervised? Now once you freeze the task, next question is think about the solution. Here, while solving it, first to think about what kind of model will fit to this scenario. Or is it like some kind of association? Is it some kind of relations or correlations? Or some other model can be fitted to this scenario. So I did about the model, the mathematical model or a statistical model. Develop a small concept, do a feasibility analysis, whether this can be deployed into the product or not. Then once you make an assessment, yes, this can be deployed, then build a small prototype, test it out. If it works, deploy. If it doesn't work, go back and rebuild it once again, then again test it out. So this process should continue till the time you get a perfect thing that is working and you tested it, verified it, then go for deployment. And till the time you are not getting the solution that you have already ideated, keep iterating. That's the next strategy. Then the fourth point here is run parallel experimentation. So not only single experimentation, we have to do multiple experimentations. Why? The same input, the same output, but we don't know the framework. The framework is something which we are asking the machine to identify. You let us know which model is most approximating the input to the output, which model is giving us best accuracy while using the input and producing the same output. So your frameworks could be changing. Your framework could be 1, 2, 3, 4, or n. It could be changing very frequently. Your input remains same, your output remains same. So run the parallel experimentation, find out the best one, compare all the frameworks together, find the best one, or probably maybe write an algo here to identify the best one. Okay, identify the or ask the machine to give always the best framework to the final outcome. How to achieve this? To achieve data driven, there are two broad ways to handle this. One is more experiments, right? So we have seen over the years, there are many smartphones which had like one single camera. Now we can see dual lenses in the cameras. Sometimes the dual lenses are vertically placed, sometimes it is horizontally placed. Some phones, the front camera is placed on the top panel. Some phones, it is placed just below the down the line. And there are other phones where you can see the smartphones where you can see the keys maybe hovering or something. Some product features are changing because they constantly experiment. They constantly change the features and they always seek feedback. Always seek, okay, what is the review? They look at the review, product reviews on popular websites, maybe Amazon or Flipkart or something. They launch the product, look at the reviews they get, and they make corrections once again. So they constantly experiment with new things. Now that is one way to achieve the data-driven decisioning. The second important way is basically learning based. Now, when I say learning, there are two kinds of learning: attribute-based learning, or it's called feature-based learning, or the other one is called content-based learning. When I say feature-based, you add one extra feature. So you remove the home button. Let's see what the people say. Then many people started complaining, okay, home button was quite easy. Now how can you remove the home button? It's not convenient, this, that. Now, okay, let's bring it back. Then they will bring it back, right? So this kind of decisioning. So learning based on product features. You make corrections to the attributes and you learn constantly. Then you make amendments to it. The other one is content based, where your context is very important, where you learn from the content and then you improve the product. For example, the recommendations, where you are supposed to give a recommendation. Let's take you are reading a blog, and the blog is, let's take, on health and beauty. You are reading lifestyle related blogs. Now the advertisements on the right hand side should display only the products associated with the, like maybe Fitbit trackers or maybe some kind of nutrient foods, etc., etc. Because this is called content based. So the content is matching. The user is reading something, the content is exactly matching with what the user is reading. So this is called content based learning. Now system understands that when you read a particular blog, you would like to see similar sort of advertisements, so that your chances of clicking those advertisements is more, because in that environment the probability of clicking on a particular advertisement is more, right? So that's why this learning based things are very important. Okay, fine. So the next step here is the strategy. Should I go for machine learning algorithms? Should I go for deep learning algorithms? Now the play here is accuracy versus explanation. Now, if you want to explain a model to someone, you would need simpler functions. Could be a simple logistic regression model, could be a decision tree where you are asking the user to explain or explaining, in fact, the algorithm to all the stakeholders. You're saying how it works. However, the deep learning models are there where you need accuracy. If you need to find out, let's take a particular molecule in some experiments, it's a very complex problem. There could be n possible combinations. So when complexity increases, you will increase the layers of algo. When you increase the layers of algo, that becomes a deep learning algorithm. Now, applying deep learning algorithm, you can achieve the task. You can predict it correctly. You can improve the classification system. However, if an algorithmic layer includes a lot of hidden layers, maybe a deep learning model you are using, it has like, let's take 23 different hidden layers, and each layer has some thousand neurons. It's very complex. We can't explain it to someone. For example, object detection while the self-driving cars. The camera is understanding the objects, differentiating objects from static objects and dynamic objects, etc. So there, the deep learning model is predicting this correctly, where we don't want to explain how the model is doing. We simply want to understand the model should be able to predict it correctly. So where accuracy matters the most and explanation is least important, then you should go for deep learning. When model explanation is more important, you have to explain exactly how the model is working, and accuracy little bit if you want to compromise, if that is okay, then you can go for the machine learning algorithms. So, but the complexity, the problem complexity, when the complexity of the problem increases, then you should go for the deep learning algorithms because one algo can't handle the classification or the scenarios. Then next decisioning about how to deploy the algorithms. Should I choose the fast algorithms or should I choose the slow algorithms? There are a set of algorithms which are relatively less complex. The runtime is very fast. For example, this naive Bayes algorithm and this nearest neighbor algorithms. Those algorithms are good for online learning. The user is doing some activities on the website. You want to predict the intent of the user. If you go for complex models, which are relatively slower, you could get more accurate results. But by the time the machine produces the prediction, the user has already logged out. You won't have, I mean, you won't have time to react. So you can produce better accuracy, but by the time you generate predictions, the user is already logged off. So you can't really show the predictions or the recommendations to the user. You need fast algorithms. When you need fast algorithms, you should go for this naive Bayes or nearest neighbor, or there are some other specific fast algorithms which are simply running based on the frequencies. Not much calculation involved, simple, frequentist, and it tells you the probabilities. So just look at the probability and start recommending. So that's how the algorithmic layer has to be chosen carefully. When your response time is less, you should go for fast algorithms. When your response time is more, then you can go for the slow algorithms. Slow in the sense, it requires more layers. It requires more functions to be evaluated. And if the underlying data is also big, so it is even more slower. So while deciding the use cases, so you have to see how much time, how much response time I have on the screen. Whatever the activity the user is doing, do I have enough response time? If yes, then I can decide based on the fast or slow, or maybe I can find out some algorithms which are in medium pace, right? Next, what type of learning? Should I go for the active learning? Should I go for online learning? Active learning is, it makes a prediction, it looks at the prediction power, it compares the scenarios where the prediction is not right, it compares the scenarios where the prediction is right. Now, those cases where the prediction is not right, It will try to introduce more parameters to improve the accuracy of the model. That's how it's called active learning. Now, this is very, very slow, but it's very powerful. So to use this in product layers, you need GPU acceleration because normal CPUs has slow or they are like having low response time. In order to have more response time, you can quickly introduce the GPU acceleration if you want to go for active learning. However, the other type of learning is online learning, where some degree of accuracy will be less, some accuracy will be like little less. However, the so far the performance is concerned, it is very fast. You can quickly predict or classify things and show the results instantly to the user. Then the last decision which you want to make is whether you want to train while the user is doing something on the website, or you want to train it in the maybe like some kind of downtime, or constantly you train when the model object is ready, you can replace the previous predict object in that train object or by taking the train object. So the training process should be done always in the batch mode, and it should be done constantly in the offline mode. Once the training process successfully completed, take the training object, use it in the prediction layer. So train versus predict decision has also to be made very carefully when you are going for online recommendations or constantly online predicting the intent of the user, classifying certain target columns here while the user is doing something on the website or on the apps. You should be using only the predict object. Training should happen in the backend. So the user or the target or the activity can be trained in the backend. However, in the front end, you can only make predictions. So these are like quick things which will help the product managers. So how it will make a difference? Typically, when we take data-driven approaches or we define the use cases, then we look for what task the use case requires. So the the product managers, while making business decisions, they should understand the baseline. They should understand the insights that the data is providing to help or to augment the product managers or the data scientists, and also helps them the decision making, and also helps them not to misinterpret the results. So the data driven decisioning helps in three dimensions. It removes confusion, misinterpretation, it removes the bias in making decisions, it removes the constant intervention of like heuristics, past experiences into decision making. It makes things more automatic, model driven, and you can put more checks and balances while the algo is taking a decision on your behalf. Constantly you look at the feedback, constantly you look at the outcome. If the outcome is not right, keep modifying, keep altering the algo, keep changing the functions. And when you see that the functions are good to and performing really well, then you can deploy it. So if we can't, like for example, the benchmark or the context is very important. So if you say, hey, if I use only the logical models, I'm getting better results. But whenever I'm using the model, I'm not getting good results. So in those conflicting scenarios, first you identify what is the baseline accuracy I'm getting, irrespective of the algo or the simple logic. So understand the context. If we have the benchmark, then we can decide how to improve the algo, how to bring more features. Can we create more intelligent features using the machines? So we can improve. If we know the benchmark, we can improve it further, and we can have like more data-driven decisioning incorporated into the products, and it can help and augment the product managers and their role in classifying, in predicting the use cases. Okay, so that's all. If you have any questions, please let me know.
Thank you, Pradeepta. That was an excellent talk.
Yeah, I'm not able to see the questions. If I
Yeah,
can
so
see
we'll
them.
share the questions with you right away.
Hmm. Okay, sure.
So we have tried to put together as many questions as possible. Uh, Pradipta, we have put together all the questions. So I think you can, it would be better if you choose to answer whatever is relevant.
Sure, sure.
I'm
So
sure
I'll go with
everything is relevant. Yeah.
yeah, sure, sure, sure. I'll go one by one. So first question is, can you give examples of the products which are using data? Yeah, almost like all the products that we see today. So we wake up in the morning, first we'll check the apps that are getting refreshed, the apps that we will be opening up first, everything is using data. So at least if you ask me, the on a daily basis, we are interacting with more than 10 applications on a mobile application, on a mobile device. We are interacting with at least 10 applications. And all those 10 applications, they have at least more than five layers of machine learning algorithms. So examples of the products, when you want to book a cab, suppose you're out of town, you are coming back to your hometown, the moment you open up the app, first suggestion would be your home. So the machine understands that in 24 hours, last 24 hours, you were not in the home location, you were in some other location. Now you came back, now you want to book a cab. So obviously, first preference would be going back to home. So the home option would come first, because that is also again using data, plus it is also using data driven. So consuming data, or APIs that consume data, and consuming data to produce some predictions or classifications. So almost all the products that we see today, they are using data definitely. So I think you are asking more about like data consumption. All the products, they are using data. Okay. Second question. In regulated industries like healthcare and finance, how do we overcome the interpretability challenges for a better AI adoption? Very good question, Vijay. Very good question. Now, here we can't roll out simply the machine learning or DL or deep learning algorithms into the regulated industries, typically in finance or healthcare. We have to do a shadow functioning, which means the models that they are using currently, they should be able to they should be able to use that. In parallel, they have to explore the capability of AI or machine learning algorithms or deep learning algorithms. They observe the concurrences or the contradictions of both the models. If the ML model, DL model is contradicting too much, probably the model is not right, or it needs further fine tuning or improvement. If mostly the model that they are already using and the AI and machine learning, it is also performing in a similar fashion or even better. So you can observe the performance of those algorithms to increase the AI adoption. Now, we need more thought leaders who can explain how the AI model exactly works. So it's not very difficult. Even a deep learning model can also be explained in a simple language. So in a logistic regression, we use one function. In deep learning, we use more than one logistic. If every hidden layer uses only the sigmoid function, it becomes like multiple logistic models you are using in one model. So if I can explain the way it is working, the way it is making predictions, then the adoption will improve, but this will take some time. The adoption in regulated industries, we have seen some tractions, like some examples of like chartboards, some examples of the algorithmic trading. So these are some areas where we have seen that the AI adoption is continuously or gradually gaining popularity. So this will improve over next couple of years. Okay, fine. The third question is, achieving targeted accuracy for a model takes multiple iterations, correct? In such a scenario, how do we identify your first MVP for initial product launch? Very good question. another good question, Vijay. Fine. So while achieving the targeted accuracy for a model takes multiple iterations, that is absolutely fine. But in this case, make sure that your input space is not changing. The feature engineering space is not changing. So if it is a matter of only iterating the model parameters, the hyperparameters, and changing the hyperparameters to improve the model performance or to improve the accuracy, that certainly can be achieved. But if your feature space is changing, the features are changing, the features that you use for model prediction, that is also changing, then I think should not be the model should not be evaluated. We are still in a phase of identifying more features. So the iterations that take more features means feature space is not completely explored properly. So you need to rework on the feature space. If the feature space is already infinite and I have already explored all the features, then it's a matter of only the prediction or the classification and improving it. So you have to fine tune the, let's take hyperparameters. Again, before launching the MVP also. So you have to tag, the accuracy should not be a constraint for MVP. You can say as and when more data will come, the accuracy will improve. So for that, you need to show some prototypes. You need to observe some or conduct some experiments and show that if let's take I have n data and n minus 1 I'll train, and if I get n minus 1 plus 1, is that improving the accuracy? Is that increasing? Suppose I have, let's take 20,000 records in my as my data set. I use only 5,000, build a model, make predictions for another 5,000 and see if it improves. Then include 10,000, make prediction for another 5,000, then see if it improves. Then include 15,000 as trend, then make predictions for another 5,000 and see if it improves. Now you are setting a trend that as and when I add more 5,000 records, it improves the accuracy. So which guarantees me that in future, if we get more data, this will improve. Okay. So hope I have answered your question, Vijay. Fine. And I would like to take the fourth question as well. How can data-driven product development help an administrative or HR professional? So what is the level of information will they need to know? Yes, thanks. Yeah, it's also a good question. So again, data-driven product development. So here, product not necessarily it should be something maybe a mobile app or a web-based platform. The product could be something like maybe a tool. It could be a simple Excel tool also. It could be a simple Excel tool also. Suppose here you want to predict, let's take attrition levels as a HR professional, attrition levels, and raise a flag in advance, saying that hey, saying to the stakeholders that hey, there is a chance of attrition, so could you address this? That's one. Kind of like generating early signals. That is one. Second could be how to motivate employees, how to bring motivation in the employees level. Should I do some kind of let's take team outing? Should we provide some kind of incentives? So what could be the reason? So conducting some survey, collecting some data, making some analysis, predicting that which teams are most motivated, how do we rank them, can we score them? There are so many things that we can do. So here the domain expertise comes into picture, and also the data, the level of data, the data available with the organization. Okay, fine. The fifth question is, how deeply should we involve data in our product decisions? Uh, yeah, thanks. So this is also a question where when I say product decision and the decisioning based on users behavior on the product or users activity on the product, both are two different things. While while we define that the product features, product decision means it could be relating to the product attributes, features, functionalities, or it could be the use cases that the product is solving, or it could be the user interface. Could be it is B2B product or B2C product. So everywhere the data is involved. Now, wherever data is present, there is some outcome which is expected from the data. There is some insight which is hidden in the data that has to be extracted. Now, for this, you apply the algo, extract the insight, then take a decision whether it is useful for the product or not. If it is useful for the product, then obviously you'll take it. If it is not, you will scrap the idea. So not necessary that data should be involved in product decisioning, but insight should always, if there is data, insight should be extracted. Now, whether the insight is meaningful or not, that's a separate thing. But whenever there is a data set, the insight has to be extracted. What the data tells us. Is that some hidden nugget which is not explored? So that is important. Okay. The next question, to what extent will AI automate admin or HR tasks in future? Will jobs in these domains get impacted? I would certainly not say that jobs will be impacted in those spaces. See, HR or admin, even the job role will improve. The job role will be augmented. So, for example, like fingerprint based attendance system, which makes the HR to collect the attendance, prepare the payroll, and here everything is automated. The employee comes in, swipes the fingerprint, and the attendance is taken. Now the HR just have to download the report and send it for salary processing, right? So manual intervention is removed. Similarly, access system. When you swipe in, swipe out, there could be like somebody else is swiping the card. Now, while doing this biometric based attendance, that bias is also gone, right? It helps the admin, it helps the HR. So here the question would be more analysis. You will be spending less time on collection of data. You'll be spending more time on analysis. So it will improve the role, the job role. It will enhance the job role. Hence, AI and automation will simplify the tasks, will give more opportunity to analyze, think, and make decisions. It will reduce the time spent on collection, assimilation, and communication. Okay. Question number 7. How often do you talk to your data scientist, ask for help, and invest in understanding the process of developing data products? See, the data scientist, if you look at nowadays, today, so if the problem statement is clearly defined and the data is available, it's okay. So they can proceed. You don't have to like talk to them very frequently. However, if your problem statement is not clearly defined, you are still inventing and you are still trying to find out what could be the solution or what other problems could be associated with this problem. So when you are at an exploration step, you continuously need to talk to your data scientist. If you have already identified the problem statement and problem is already framed, then probably you don't have to talk much to the data scientist. I hope I have answered your question. Okay. Yeah. Question number 8. Is product management person audience feedback giver? Product management person, okay, in data driven product development, or is a participant? If participant, how? Good question, Himanshu. Yes, so product management person. So when you are managing the product, you are basically communicating from requirement gathering. So you are collecting the requirements from the stakeholders. You are communicating it to the development team. You are communicating it to the data. So here, the product management person or the audience. So audience would be, I would say, is the feedback giver. Product management person is not giving a feedback here. Okay, because you are designing the product for someone. Like smartphones, we are designing for the consumers. Now consumers should be giving a feedback. If the feature of, let's take dual camera, is not good enough, the consumer should give a feedback, not the product development person who designed the dual camera. It is the consumer. How? There are various platforms. You can give a formal statement or formal email to the company saying that, hey, this product is not working, the dual camera is not working, the phone is hanging. Then you will get a call from the company saying that, hey, can you just go to our service center and drop your phone? We'll replace it or we'll probably give a new phone to you, right? Then your feedback is heard, correct? So that's why the person or the consumer is basically a feedback giver. This trick seems to be great. How much percentage approximately business we can bring in terms of probability if you have already tried this? What is that? I didn't get this question.
Sorry, which one was that?
9, question number 9.
Question number 9. Much percent. I think this was he was reacting to something you were saying earlier. So Raghavendra, for now we are going to skip over this question. Please write to us if you want. If this is not what you meant. I think
I still,
Pradeepta, we will skip over to the 10th.
yes. Depending on the nature, velocity, and volume of data, can the machine learning algorithm itself be chosen on the fly? No, no. It can't be chosen on the fly based on the nature, volume, and velocity of the data. It could be simply the tasks. So if you want to classify something, if you want to predict something, you want to forecast something, you want to recommend something. So based on the task, it would be different. Okay, fine. The 11th question is, can you please elaborate more on active and online learning? Good, good question. The active learning is, so I'm referring to the Keras framework. So if you are familiar with the deep learning library, you have Keras. So Keras provides a framework called active learning, where it first makes the prediction or the classification. Then it makes an assessment of how good my prediction is, how good my classification is. It tries to find out those cases where the prediction is poor, where the prediction is less important. Now it separates those cases, trains it separately with the same hyperparameters, and tries to make an assessment once again, whether this is good or bad. Now it tries to improve the classification, it tries to improve the prediction till the time the prediction power is more, and that is defined by a function. So you can explore more on the Keras function on active learning. However, the online learning is something where you are not taking the algo's feedback about how good or bad the prediction is. You are simply aligning or associating more records to the model, and you are simply making predictions. So online learning is continuous, active learning is iterative.
Mohit, could you move on to the next slide? Thank you.
Okay, this one is data-driven algorithm similar to personalization by understanding customer segments? Yes, that's right. Given the many tools and techniques, what is the suggested skill or tool for product managers to learn quickly and apply? Well, for product managers to deploy the data science techniques and tools, so I would recommend the Python as a great tool to be used. So Python's potential in terms of deploying the machine learning and deep learning algorithms are also great, and its compatibility with the other frameworks quickly it can get merged with, or you can use it with the other platforms like Spark platform, could be TensorFlow, could be PyTorch. So you can use it with other platforms as well. How do we determine the success of chosen algorithm? Of course, that you have to decide. So the success parameter or the metric, so you have to define that. For example, if you have a classification system, you'll be looking at the F1 score, which is called the harmonic mean of the precision and recall of a classification. So one single metric, you will define how good the algorithm is. Now, if it reaches a threshold of, let's take 0.80, we'll say it's a great algorithm. That's for a classification system. If it is for a regression related problem where you are trying to make predictions, then we're looking at the mean square error, MSE, or mean absolute error, MAE, to improve the algo. Again, you will decide if, let's take, prediction is accuracy is 80% or more than that, it's probably a good algorithm. Fine. What are different ways to validate the predictions, especially the deep learning algorithm? Correct. So in deep learning, again, it depends on the success criteria that you define and the framework. In deep learning, there are three frameworks: CNN, DNN, and RNN. CNN is mostly for the image processing. RNN is mostly for audio processing and the text processing. And the DNN is for structured data. Mostly it is used for structured data predictions. Okay, fine. Then, yeah, how to validate the predictions? Of course, you have to observe certain predictions and you have to see how the predictions are going. How data-driven products can be useful in healthcare sector and be helpful to save life? Of course, yes. There are many products out there in the market. For example, prioritizing the imaging system, that is imaging scans and all. Understanding from the imaging system, prioritizing if a case needs special attention or something like that. So that is imaging analysis. Then the from the gene patterns, we're trying to predict that which medicines will react to which type of genes and all. So there are so many research papers around this. You can explore this archive.org to find many papers around this. Okay. So Menka, you'd like to conclude here, or you want me to continue
We
answering the
can
questions?
we can go for another 10 minutes, and whatever questions you can take within that time we can take. So I have sent a message to the entire audience. Apologies, we don't have that much time now, but any questions that we have not answered here, we will be answering it through our LinkedIn page. So Pradipta, you can take as much as you can take now, because thank you so much. You've answered so much already.
Okay, welcome.
So,
Question number 15. It's about, could you please let us to what extent the data science knowledge is required for product manager? Correct. So when you say product manager, see, if there is some kind of a decisioning in your product, and so decisioning could be, okay, let me explain what could be the decisioning. Decisioning could be if I'm, let's take, cab aggregator. So the user is searching for a cab. I'm just making it available for the user and just looking at the availability status of all the drivers. If a driver is available, so I'm just displaying the message to the driver, hey, you accept this request. If the driver accepts, and you're just allocating that cab. That's the cab aggregator example. Now, where the product managers, or exactly where the data science will help the product manager. Now, if a question is Monday morning 7 to 9, how many cabs I would need nearer to a particular city or nearer to the airport? Or how many cabs should I need or would be required? In fact, let's take a Friday evening for a particular airport. Now that's where you need data science. So as a product manager, so if you want to estimate the demand, then you can allocate your resources accordingly. You can gather the cabs at a certain place where the demand is most. So that's how the data science will help you in predicting the demand so that you can allocate your resources properly. Now, if that is the role of a product manager or not, that I'm not sure. So that you again, so the role, if the product manager's role involves decision making, then certainly there is data available, then certainly you can use data to make decisioning based on data science. 17, I have a question which is very critical business decision. I'm working on validating a product ideation where we're thinking to get on cloud solution or for our on-premise one. How can we work on getting data for such? decision. Yeah, it's complex one, Gomati. Yes. Uh, See, the question, because here there is, I mean, on premise or on cloud, uh, see what factors impact, and those factors, are they captured in data or not? I'm not sure. So I'm sorry. So I would not be able to answer this question. How do you learn all these concepts? How much time does it take to learn and get expertise in them? Aditya, well, so these concepts and to learn it, it's a long term. So, I mean, if you ask me, took me around 10 years. 19, where can we get some examples of each of them? For example, NIBIS or SVM. Is there a single placeholder open forum along with the data? Yes, Pinat, yes. It is there in scikit-learn. So sklearn is official documentation so it's an official machine learning library in Python. You can explore the algos. It's in one place. Official machine learning documentation in scikit-learn. Machine learning needs lots of data. Obviously, that's true. Better data achieve good results over complex algos. That's right. Companies like Google, Amazon, Microsoft have this advantage. How do startups overcome this challenge? Yes, again, that's a good question, Vijay. Yes. So to do that, the only way is basically replication, simulation, and performing experiments on the simulated data. That's the only solution. What is the best way to solve two language problem while deploying the model in production? What is the best way or language to solve this? Okay, so when you say two language, is it like English, Spanish kind of example where you have two different languages you want to make a model to predict the language? If that's the case, then you have to train a large corpus to achieve it.
So, thank you so much, Pradeepta. You have been very patient with all of us. And thank you, everybody, for this wonderful questions and interaction. And Pradeepta, we need to, I know there are a lot of questions yet to be answered. Please send in a mail to menaka at ipl.edu.in. We will get it answered based on Pradeepta's availability. And we need to find the best question, the winner for this webinar, Pradeepta. I would ask you to choose the winner. So you can send me a chat or text on that, or perfect. So Vijay, you are the winner. Congratulations. So here is the Mohit. Could you show the book which he'll be getting? Okay, perfect. So this is the book by Pradeepta, which is currently being taught in the Pittsburgh University. So this is your gift, Vijay. Please drop in your address, postal address to menaka at edu.in. We will be getting the gift. And Pradeepta, thank you so much again. And thank you all the delegates for your patience. And we will be coming up with more events. I'll be sharing this presentation, Pradeepta's presentation and the webinar recording and the upcoming events, everything with you over the mail. Thank you again. Please keep watching our website for more events.
Yeah,
Thank you so much.
welcome, Enka. Thank you so much.
Thank,
Thanks. Bye bye. Bye.
bye.